Afternoon, folks. I've had just one response to my request on issues that you might need some help with. This is question 3 from the C6 test, parts F and G. It's part G that I want to go through in a lot of detail. Part F is a flow chart and it shows the bauxite ore, 5,600 kilograms, is crushed and separated from the waste, which gives us 2,500 kilograms of bauxite. That's then purified and we get 1,950 kilograms of aluminium oxide. That's electrolyzed and we produce 1,000 kilograms of aluminium from that. Okay, so the first question was asking about the yield of aluminium oxide from bauxite. So it's 1950 divided by 2,500, which is a 78% yield. Now, the main part of the calculation here, we're looking at calculating the mass of aluminium produced, which is 1,000 kilograms. We will compare that with the expected mass, and we're going to state the difference in the mass to 3 significant figures. Okay, so all of that information is key. You'll have to excuse the dogs and the sing-song. So first of all, we're going to write the equation. So aluminium oxide is going to produce aluminium and oxygen, and we want to balance that up. So let's make that 2, that 4 and that 3. Okay, so 2 moles of aluminium oxide produce 4 moles of aluminium and 3 moles of oxygen gas. First thing we then do is write our information in. We've got 1,950 kilograms of that, and we want to know what the theoretical yield is of that. Step number 1, convert mass into moles, and we do that by taking the mass, 1950, and we're going to divide that by the formula mass MR, which is 1950 divided by, now the MR of aluminium oxide is going to be 27 plus 27 plus 3 lots of 16, which is 48. So 1950 divided by 102, which is what that comes to. Okay, so throwing that in the calculator, that gives us 24.51 moles. Now what I've done, I've left that in my calculator, so I'm going to use a running calculation. Then I won't end up with rounding errors at the end. So we have 24.51 moles of aluminium oxide. 24.51 moles. Okay, so now we can compare directly the number of moles of aluminium we're likely to produce. Since 2 moles makes 4 moles, then we've got a reaction ratio here of 1 to 2. So second step, reacting ratio is 1 to 2. So if we have got 24.51 moles of aluminium oxide, it's going to produce twice as many moles of the aluminium. Okay. So now we know how many moles of aluminium we're going to produce. In theory, remember this is expected. So part 3, we want to convert the number of moles into a mass. So moles multiplied by AR equals mass. So we've got 49.02 multiplied by the AR of aluminium. So you find that on the periodic table, it's the mass number, 27. And that will give us a mass of 1324 kilograms. So that's the expected mass. That's the actual mass, okay? So they want to know, state the difference in the mass of 3 significant figures. So it's going to be 1, 3, 2, 4, subtract 1000, which equals 324 kilograms. You're done.